moving on to our third video in this series, we're going to first look at comparing P to our level of significance, and then we're going to use a StatCave spreadsheet, StatCave calculator, StatCave hypothesis test decision maker to help you do some of these. All right, first of all, let's just say that we have a situation where we are just given a p-value and a level of significance. In other words, determine whether or not we should reject or fail to reject the null hypothesis at the given level of significance. First of all, a level of significance of 0.10 or 10%. All right, my null is that the population mean is equal to 37. My p-value is 0.062. Remember, if p is less, please reject the null. So in this case, for a level of significance of 0.10, we're going to reject the null. However, in B, the level of significance is down to 5%, or 0.05. Comparing 0.0652 to that value, it's greater. If P is greater, maybe later, but not now. So do not reject the null. We fail to reject the null. Now here's another question. Test the following claim about the population mean mu at the significance level noted using the given sample statistics. Assume the population is normally distributed. The claim is that the population mean is greater than 900. Alpha, or the significance level, is 0.04. Population standard deviation is 100.75. We have found the sample mean to be 926.35, and we sampled 175. That's my sample size. Now, first of all, in doing this, it is set up, all right? I've got a spreadsheet set up that I will share with you. I want to show you some parts of it before we use it. The claim, or the value associated with the claim, is the red circle. It will be entered here where it says hypothesized value. Alpha, or the level of significance, is the blue circle. It will be entered there. The population standard deviation is entered where it says population standard deviation. The sample mean, or X bar, is entered right here, 926.35. The sample size is entered right here. And when you enter these things, it is going to give you both the test statistic to 3 decimal places, 3.460. It's going to give you the p-values for 3 scenarios. If your null hypothesis is that it's equal to 900, the value put here, greater than or equal to 900, or less than or equal to. So you have to understand that, all right, with a claim that the mean is greater than 900, the complement of that is that it's less than or equal to. So the claim in this case is the alternative hypothesis. The null hypothesis would be that it's less than or equal to. So I'm looking right down here that the mean is less than or equal to 900. I reject the null. Since our alternative was that it's greater than 900, our null is that it's less than or equal to. So we find our p-value right there. It bases this, it looks and says, okay, is this p-value less than the level of significance? Yes, it's a lot less. If p is less, please reject. It's right there. Notice when I pull this up, there's 3 tabs. There's tabs for doing a z-hypothesis test, or when the population standard deviation is known and the sample size is greater, and or the sample size is greater than 30. T for when it's less than 30 and the sigma is unknown, and doing proportion hypothesis test. So this, of course, I had a sample size of 175. Let's do this one. So first of all, down here I want to make sure that I have the Z, sigma known, n is greater than 30. Not this one, not this one, but this one. So I enter my sample size. It was 175. I enter my sample mean, 926.35. Only enter in green cells. Don't mess with anything else. Population standard deviation. I enter alpha. I enter the hypothesized value. It gives me the test statistic. I have to understand that since my claim was that it's greater than 900, my null hypothesis will be that it's less than or equal to 900. There's my p-value. The decision will be to reject. This covers everything, but you have to understand what the null hypothesis is. So we have our answer on that one. Let's do another one. A random sample of 100 recreational basketball coaches scores, I need an apostrophe there, on a child safety test has a mean of 88. These results cause the National Association of Coaches to claim their mean on this test is at least 85. Assume the population standard deviation is 3.5. At an alpha of 0.08, is there enough evidence to support the National Association's claim? First, the claim is that the mean is at least 85. That means that it's 85 or more, so they're claiming that the mean is greater than or equal to 95. This is very important. Since that claim has equality in it, it's the null hypothesis. So we have null, that is greater than or equal to. The opposite or complement of that would be that it's less than 85. Now, I'm going to stop right here and note if they had said more than 85, not at least 85, but more than 85, that would make the claim an alternative hypothesis, and then the null would have been less than or equal to 85. Just as a note, let's go back to the problem now. A random sample of 100 basketball coaches. Okay, so my sample size is 100. Had a mean score of 88. My sample mean is 88. We assume the population standard deviation is 3.5. There you go. At an alpha of 0.08. There it is. Here's my hypothesis, null hypothesis, alternative. We put the values into the spreadsheet, and remember that the null hypothesis was that it is greater than or equal to 85. We're going to fail to reject that. All right, there's my test statistic. Here's my p-value. So we fail to reject the claim. How are we going to say that? What does it mean? At the 8% significance level, there is not enough evidence to reject the association's claim that their coach's score on the safety test is at least 85. That's the way we say it. Let's look at another one. A pizza delivery company randomly sampled 35 driver times to deliver pizza for their national chain. Assume the population standard deviation is 4.3 at an alpha, I should have made that a Greek A, of 0.05. Is there evidence to reject the claim? Okay. That the mean time for drivers to deliver pizza is 32 minutes. Is 32 minutes. They're claiming it is 32 minutes or it is equal. They just give me the data here. They don't give me the sample mean. But first let's look at this. They're claiming that it is 32 minutes. So the claim is the null. The mean is equal to 32. The alternative would be that it's not equal to 32. Now, what do we do with this data? Just go to Excel and find the average of it. Use the average function in Excel and find the average of this data is 30.63. Now I have all of my information. There were 35 data points. The sample mean was 30.63. The population standard deviation, they said to assume 4.3. The alpha was 0.05. All of this is in here. All right, here's my null, my alternative. I go to the spreadsheet, which I will share with you on my website. I plug everything in. Here is my test statistic. Here is my p-value. If p is less, please reject. But p is greater than alpha, so I'll wait till later and fail to reject the null. So what do we have? The standardized test statistic, negative 1.89, right here. If you had to round that to 2 decimal places, it would be negative 1.89 versus a p-value of 0.059. Whoops. Right here, if I rounded that to 3 decimal places, 0.059. Okay. Now, so p is greater than alpha. So as the spreadsheet notes, we fail to reject. P is greater, wait till later, we can't reject it. So we would say there is not sufficient evidence to reject the claim that the pizza company's mean time to deliver a pizza is 32 minutes. Between you and me, they should have claimed that it was less than 32 minutes. Think about that. If they said our delivery time is less than 32 minutes. So that would make that the alternative in that case, and then the no would be that it's greater than or equal to 32 minutes. Let's go back up. We would have rejected that and accepted that it was less than 32 minutes if they had said it that way. It just sounds better. Anyway, I think we're going to look at t-test in the next video, or t-hypothesis test. Hypothesis test where we use t.